Hi everyone. So today we will be learning the difference between covalent and ionic compounds. I have actually created a similar video prior to this, but I think I haven't really discussed it well. So this video is a prerequisite learning before before you proceed to the naming these compounds later. So to name covalent and ionic compounds, let us first define what covalent and ionic compounds are. So let's start with covalent. So covalent is also known as the molecular compound. Molecular compound. Covalent compounds are pure substances formed when atoms are linked together by sharing. The word is sharing of electrons. So covalent compounds are formed through, of course, covalent bonding and commonly occurs between nonmetals or between two of same elements. So when we're talking about covalent compounds, we have nonmetal plus nonmetal. A common example would be like water or H2O. And it's also formed in between two of the same elements. So we have, let's say, chlorine gas. So it's the same, it's a pure element compound. While ionic compounds are formed due to transfer of electrons. So the term for ionic compounds is transfer. And these are formed due to the transfer of electrons or electrons being transferred to the negatively charged, let's say, atom. So, of course, it is formed through ionic bonding, and a common example would be, since it's ionic bonding, have non-metal plus metal. So this ionic compounds are often between non-metal plus metals. So a common example for ionic compounds is NaCl. So we have the sodium positively charged and the Cl negatively charged. And we also have um, calcium carbonate, where the calcium is positively charged and the carbonate ion, this is an ion, we have negatively charged. And observe that sodium here is an alkali metal. This is a metal, and the chlorine is, of course, a non-metal. This is a halogen. So to further illustrate how this sharing and transfer happens, let us go back to the covalent compound. Let's look at this H2O. So let's say that we have um, we know that oxygen here has 8 valence electrons. It has 8 valence electrons. The first level, based on your electron configuration lesson, the first level has can carry 2 electrons. The second energy level can carry 8. Have 4, 2, 4, 6, 7. And we also know that hydrogen can carry 1. Has one electron, valence electron. And since we have two hydrogens, we have something like this. So what happens when um, the elements in a compound share is that they both approach each other in a way that nothing is replaced, but they are bonded covalently. So it'll now look like this. Oh, they are covalently bonded covalent compounds. And coming from the oxygen. So this is what covalent compounds sharing looks like. So for the ionic compounds, we have let's illustrate NaCl. We have we know that um, the sodium has 11 valence electrons. So I think you already know how we determine the number of electrons. This is from, if you recall, from the other videos I made. We can solve this through number of protons equal to the atomic number, and number of neutrons, mass, is equal to mass number minus atomic number. And the number of electrons, atomic number minus the charge. So I'll just link the video, uh, the, the video I made solely for this topic, and let's proceed to the illustration for the transfer of electrons between ionic compounds. So when you look at sodium, um, you can see that it has 11 valence electrons. So we have um, three three energy levels for this. Hmm. And we have, since it has 11, the first energy level can carry 2, the second energy level can carry 8, and we have 2, 4, 6, 8, 10, and the 11. And now we have um, the electrons for this is 11. And when we have the Cl part, let's use another color. We have Cl. The chlorine has 17 valence electrons. So it requires 3 energy levels as well. And then we have, let's use another, say orange. The first energy level can carry 2. The second energy level can carry 8. And since it's 17, we have 2, 4, 6, 8, 10. And the third energy level can carry 18, but we only need 17. So we have 2, 4, 6, 7. So we have a total of 2, 4, 6, 8, 10, 7. We have 17 in total. So the number of electrons for the chlorine is 17. And if it's ionic bonded with sodium, this electron in the outer shell will transfer here. Then it will have 18. 18 together, they have this compound has a 28 number of electrons. So this is how it looks like when they since sodium is positive, this positive atom or element donates to the negatively charged atom. So chlorine receives while Na donates. So this is how the um, transfer looks like. So um, together this is called sodium chloride. So the next video will tell us why is it named sodium chloride. Chlor how did it came or how did the suffix ended with "ide"? So this is a prerequisite lesson to naming covalent and ionic compounds.